iteration method to determine an approximate root for an given equation. Okay. Now, if you observe the rate of convergence again for iteration method is very slow. Means what you require at least 8 to 10 steps. This convergence you can accelerate by using an Aitkens delta square process. So, if you apply this new process, you must have at least 3 iteration from iterative methods. So now today we are going to see Aitkens delta square process. Now to apply this process, you must have a 3 iteration. You must have 3 values, say x1, x2 and x3. You have determined these 3 values by using and iteration method. Then you can find the value of x4 by using the Aitkens delta square process. x4 is equal to x3 minus delta x2 bracket square divided by delta square x1. Now how to, in this process you know how to determine the x1, x2, x3. These values we can determine by using the iteration method. Now you know the x3, but how to determine this delta x2, delta square x1? We are going to see details about this operator in the next chapter, interpolation. But now since we require here the delta x2 value, delta x2 is nothing but it is a forward operator. Okay, what is delta f of x? It is f of x plus h minus f of x. Means what, if you want to determine delta x2, so it is what? x3 minus x2. What is delta x2? x3 minus x2. This is the first forward difference. And if you take the second forward difference, then it is denoted by delta square. We are going to see this detail by using an example. Again, why we need an Aitkens delta square process? I am again repeating. If you observe the rate of convergence of iteration method is very slow. Okay, to accelerate this, आपल्याला जास्तीत लवकरात लवकर सोल्यूशन मिळवण्यासाठी आपण Aitkens delta square process apply करणार आहे. So write down next example. Use method of iteration to determine the root of the equation x is equal to x e raised to x is equal to 1. Okay, and then apply Aitkens delta square process. Okay, you have to use an iteration method, and then you have to apply an Aitkens delta square process also to accelerate your solution. Okay, so this is the given equation. This is a given. In this example, we are going to see that in details what happened in iteration method and what happened in Aitkens delta square process. Again, already I have told you that these are all the bisection method, regular policy method. They are all these methods gives an approximate solution to algebraic equation also and transcendental equation. If you observe, this is the transcendental equation because it contains an exponential function. Okay, so now to determine the root of this equation, what is our first step? We want to write this equation in standard form. F of x is equal to x e raised to x minus 1. Now to determine an interval containing root, we start always from 0. So if you put f of 0, you will get 0 minus 1 is minus 1. F of 1 is equal to 1 e raised to 1 minus 1. All of you know that e is what? 2.71 minus 1. So it is greater than 0. This is less than 0. Okay, 2.71 minus 1 is what? Greater than 0. So if you observe, these two are to have an opposite sign. So f of 0 into f of 1 is less than 0, and therefore root lies in the interval 0, 1. Okay, now once you identify the interval containing an root. Next step is what? Step number 2. We want to write our equation in the form of x is equal to phi of x. Again, there are two ways. Either you can write this 1 by x here, then inverse of e is what? Ln 1 by x. Second method is what? Write down this x here and e raised to x here. Okay. So if we write this x is equal to 1 upon e raised to x, then we want to check whether it is our phi of x. For that, compare with x is equal to phi of x. We can observe here phi of x is equal to 1 upon e raised to x. Now that is e raised to minus x. So if you take the derivative of phi dash x is equal to minus e raised to minus x is equal to minus 1 upon e raised to x, and if you take the mod of phi dash of x, then it is what? It is equal to 1 upon e raised to x, and it is less than 1. Why it is less than 1? Because 1 upon e is what? 2.71. So this is 1 upon e raised to x is less than 1 for every x belongs to R, and therefore we can select this is our phi of x. We can select this is phi of x. If it is not less than 1, then again we want to transform this equation in such a form that your phi dash of x must be less than or equal to 1. But here in the first case, we have obtained directly that our phi dash of x less than 1. So this is what? This is what our phi of x. Now, once you identify your phi of x, next step is what? Step number 3. We want to determine 3 roots by using step number 3. Since phi of x is equal to 1 upon e raised to x or e raised to minus x, we want to determine 3 roots by using an iteration method. Now again, to apply an iteration method, we must have an approximate root. Okay, since our root lie in the interval 1 2, you can select 0 1. You can select any number in the interval 0 1. आपला रूट हा 0 1 मध्ये कोणताही अप्रॉक्सिमेट रूट घ्या जो 0 आणि 1 मध्ये. सपोज वी हैव सिलेक्टेड x0 is equal to 0.5. x0 is what? 0.5. Then what is x1? x1 is what? Phi of x0 is equal to 1 upon e raised to 0.5. So if you use your calci, you will get 1 divided by e raised to 0.5. So it is what? 0.6065. So this is what? x1. This is x0. We have selected from our interval. This is what? x1. Now x2 is equal to phi of x1 is equal to, so 1 divided by e raised to 0.6065 is 0.5453. This is what? x2. Now x3 is equal to phi of x2, so it is equal to 1 divided by e raised to 0.5453. So it is what? 0.5796. So this is what? Now to apply Aitkens delta square process, we must have at least 3 roots from iteration method. So since we have determined the x1, x2, x3, now apply Aitkens delta square process. Okay, now to determine an Aitkens delta square process, so this is what? Make this table. In x, write down x1 0.6065, x1, x2 0.5453, and x3 0.5796. So now find the delta x. Delta x. So what is delta x? Is x1, x2, x3. So what is delta? It is a forward operator, that is 0. Delta x1 is what? Delta x1 x2 minus x1. x2 minus x1. So 0.5453 minus 0.6065, you will get minus 0.0612. Okay, now what is delta x2? हा झाला delta x1. आता delta x2 म्हणजे काय? x3 minus x2. So 0.5796 minus 0.5453 is equal to 0.0343. So this is delta x1, here delta x1, हा delta x2. आता आपल्याला फाइंड करायचे डेल्टा स्क्वेअर x, म्हणजे आता आपल्याला आपण डेल्टा x3 ने फाइंड करू शकत नाही. डेल्टा x3 फाइंड करायचं असेल तर आपल्याला x4 आणि मायनस x3 करावं लागेल, पण आपल्याकडे x4 नाहीये, त्यामुळे आपण फक्त डेल्टा x1 आणि डेल्टा x2 फाइंड करू शकतो. इथे बघा डेल्टा x1 आहे, डेल्टा x2 आहे, म्हणून आपण डेल्टा स्क्वेअर x1 फाइंड करू शकतो. तो तुम्हाला काय मिळेल बघा, डेल्टा x2 मायनस मायनस म्हणजे मायनस मायनस प्लस होणार आहे डेल्टा x1. सो 0.0343 plus 0.0612. It is what? 0.0955. So this is what delta square x. x1, x2, x3, delta x1, delta x2 and delta square x1. Delta square x1. Okay. Now, what is Aitkens delta square process? To determine x4, what is the formula? x3 minus delta x2 bracket square divided by delta square x1. So it is equal to x3. So what is x3? 0.5796 minus delta x2. So this is what delta x2? 0.0343 bracket square divided by delta square x1. So this is delta square x1, 0.0955. Okay, so if you solve this, you will get 0.5796 minus 0.0343 square, 0.0343 square divided by 0.0955. So this is equal to 0.0123, and to subtract 0.5796 minus 0.0123, you will get 0.5673. So now we want to determine root must be correct up to 3 decimal places. So what is our answer? Answer is what? 0.56